Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be looking into electromechanical devices called relays. This video is divided into 5 important topics. First one is what are relays and their working principle. Second one is types of relays and their ratings. Third one is selection guide for relays and their circuit diagrams. Fourth one is applications of relays in industry. Last but not the least, fifth one is advantages and disadvantages of relay. So let's start. What are relays and how does they work? Relays are electrically controlled mechanical switches. It operates on the principle of electromagnetism. In simple words, relays are electromechanical devices which operates with the low capacity voltage to control the high capacity loads. When a DC voltage is applied to the coil or induction coil of the relay, it will generate a magnetic flux. This magnetic flux indeed creates the magnetic force towards the contact point. So this is how the entire relay works in electromechanical industry. There is no electrical connection between a load side switching and the driver side circuit. Hence, it will provide the galvanic isolation between the high current load and the low current switching signal. Now let's talk about the types of relays and their rating. There are varieties and countless number of relays available in the industry based on their variety of applications. However, with the categorization of working principle, operation methodology and connection points, we can understand them much better way. Based on the working principle, relays are categorized into 3 categories. First one is electromechanical relay. Second one is solid state relay. Third one is reed switches. Based on the connection points, these relays are categorized into SPDT, DPDT relays, which means single pole dual throw or dual pole dual throw. When it comes to current rating of the relay module, it is limitless for the designers or electrical engineers to select a relay for their application, because it is possible to have a relay with a 5 ampere of a current rating at the load level at the smallest dimension on the PCB. At the same dimension, we can even find more than 70 ampere of switching capacity of the relay. If you go for a panel mount relays, then there is a relay available for more than 200 ampere of current rating switching capacity. So the relay with a current rating, there are variety of options available for the designers. Based on the applications, based on the requirement and based on the factor of safety, we select a specific relay for a specific application. Now it is time for talking on selection guide for relays and the circuit diagram for them. It is very straightforward to select a specific relay for a specific application if your load condition is defined. If it is not defined, if you are having a variable load condition, then with the help of factor of safety, we can select a specific relay for the application. Let us assume that we have a requirement of 1 kilowatt of AC signal switching with a relay module and having a driver circuit with using microcontrollers which operates at 5 volt DC. In this case, we have to select a specific relay which operates at 5 volt DC signal at the input side and it is capable of switching 1 kilowatt of power at the load level. With the factor of safety, it is better to select more than 1 kilowatt, but we are considering maximum of 1 kilowatt in the assumption itself. In case of electrical equipments, contactors and the PLC circuits are used for switching the AC signals, which operates at 24 volt DC because PLC operates at 24 volt DC in the input side as well as at the output side. However, when it comes to microcontrollers and electronic digital circuits, they operate at very minimal voltage like 3.3 volt or maybe a 5 volt. On that time, we have to carefully select our relay which has a capacity to switch with the voltage of 5 volt. Otherwise, we have to use another switching circuit to drive the relays, which are so called drivers. For galvanic isolation between the relay circuit and the microcontroller circuit, we can use basic optocouplers because they provide a very good galvanic isolation between high voltage relays and the microcontroller circuits. Having said that, now it is time to talk about the applications of relays in industry. There are thousands variety of applications available in industry. Wherever with the need of electromagnetic switching, relays are used. That's why the relays are available everywhere. In any industry you consider, relays are there. In case of a PLC modules for industrial automation or industrial control system, there are relays used at the input level and output level. Because without using the relay modules, it is not possible for the digital circuit like a PLC controller to control the AC signal switching. If you consider automotive industry, most of the peripherals are switched by using a relay module with a signal from ECU, which is nothing but a DC signal. And if you consider a low budget DIY home automation devices, which are again made up of relay modules inside. Recently, I have seen a 110 volt DC relay used in Indian Railways for switching the pneumatics. That's why relays are everywhere. If you consider automotive industry, if you consider a medical industry, if you consider industrial automation, everywhere you can see relays are widely used based on the application and based on the requirement. Let us conclude this video with the help of fifth point, that is all about advantages and disadvantages of the relays in industry. Let's talk about the advantages first. First one is relays are having a no contact between a switching side and the load side, which means there is no direct electrical contact between the AC signal or a DC signal that is switching at the high capacity load and the DC small capacity signal provided for the coil. That's why they are very safe to use in industry. Second advantage is they work very well in high temperature environment because they are enclosed with the plastic enclosure and they are having a very good construction inside, because of which they work very well in high temperature at industrial level. Third advantage is they are very easy to connect, they are very easy to use, and they are very easy to connect with electrical circuit because they have hardly 2 to 3 points to connect as per the application and the construction. The coil has to be provided with the proper DC voltage and the contact points to be provided with the proper AC switching voltage. That's why it is very easy to use and connect. Fourth important advantage is the relays can be used for switching a AC voltage or a DC voltage at the load level. It doesn't mean that only you have to use AC switching at the load side. You can even use a DC switching as per your requirement. It doesn't make any difference to the circuit, neither to the relay operation. That's why they are very easy to use and very widely used in industry. Let us consider a couple of disadvantages of these mechanical relays. First one is these relays get oxidized and weakens their contact strength over the period of time. Because of magnetic principle or because of electromagnetic induction, the contact point of the relay becomes very weak and get oxidized over the period of time, which will malfunction or reduces the capacity of load switching over the period of time. Second major disadvantage is they generate a switching noise. When they are switching from one point to another point, they create a tuck kind of a noise, which is not so good in case of very microelectronic circuit or very industrial application where noise is very critical point of consideration. Third disadvantage is these relays, which are electromechanical relays, cannot be used for high switching frequency or high switching principle. Say for example, if you want to switch any signal with a frequency of 1 kilohertz, you cannot use relay for that purpose. Relays takes their own time from switching one point to another point because of magnetic flux generation requirement. The fourth important disadvantage we have to consider is the designer has to consider the IPC standards for the PCB mount relays when they are designed with the IoT application or wireless communication devices. If you are keeping any antennas or wireless devices near to the relay module, it may malfunction because of electromagnetic induction principle. That's why it is very difficult to design a wireless module board along with the relay module in the same embedded system. Alright, this is all about the relays and their application in electronic industry. I hope you enjoyed and learned something new about relays in electronic industry. See you again in the next video. Until then, happy learning. Namaskaram.